Hello friends, my name is Amit. Welcome to NGT and Quality YouTube channel. So friends, in today's video we are going to see about gamma ray characteristics in radiography testing. So in radiography testing you mainly use two waves. Waves or rays are called this. One is X-rays and the other is gamma rays. So these are two waves. We do radiography using this. If we talk about gamma rays in this, then you can get gamma rays in two ways. One is that you get gamma rays naturally, meaning there are some elements that give you radioactivity naturally. And some elements and their isotopes are such in which we create isotopes artificially and use them for radiography. So there is a special artificial isotope. We do radiography here using it. Whenever you use iridium-192 or cobalt-60, always remember that we use artificial isotopes in it. So we will discuss all these things in this video. Apart from this, nuclear fuzz process is used here. When you create artificial isotopes in it, then apart from gamma rays, you also get to see alpha and beta particles. Meaning, these are also found. So how are they different? These rays mean that they are waves and both of these are called particles. Right? So here we will also cover the difference of all these in this video. So suppose you are going to give the RTFI Level 2 exam in PCL, then you are asked questions related to it. So definitely watch the video till the end, and if you have not yet subscribed to our channel, then definitely subscribe to the channel and share this video with your friends and colleagues. Apart from this, you can take membership of the channel by using the joint feature. So we have also made many Member X videos. In this you will get the complete syllabus of NDT Level 2. Apart from this, we have also made many videos of code standard interpretation evaluation, in which we have made a lot of videos in detail mainly on ASME code, AUS API code, ASTM standard. Apart from this, you will also get videos of practical NDT in which we have explained practically on the actual NDT instrument how NDT is performed. So to get access to all these videos, you can use the joint feature and support me financially. So, if we talk about gamma rays, then first of all in radiography, in industrial radiography and nuclear science, gamma rays play a critical role in detecting faults and ensuring the integrity of materials and components. So it is very important that we use gamma rays in radiography testing. And especially when there are components of heavy thickness, X-rays cannot be used here. Meaning, the result will not be as effective. In that case we use gamma rays. But what exactly the gamma rays are and why are they so essential in non-destructive testing we will see in this video. So see, what are gamma rays? So gamma rays are high-energy electromagnetic waves with extremely short wavelength measured in nanometers. So here first of all these are electromagnetic waves. So for this, if you look at the electromagnetic spectrum, you will see many different types of waves in it. This is the electromagnetic spectrum. You should have complete knowledge of it. Suppose you work in NVT, then you should have a complete idea about it. Because this same spectrum is used for radiography and visual testing. And there are many other theories which are used in different methods. Electromagnetic spectrum is used in it, meaning you can understand by using it. So if you look here on the left side, it is written gamma ray X-ray. And what is written here 10121010, all these are the wavelength of radiation. Right? It is a wavelength, so you call it lambda. And it is written on the bottom side that it is frequency. So the relation between frequency and wavelength is like this. Lambda equals V, F or F equals V, lambda. You can write it like this. So simply both of them are opposite to each other. Meaning if one increases then the other will decrease. If one decreases then the other will increase. So they are opposite to each other. So here you can see that the wavelength for gamma ray X-ray is very short. Meaning it is very low and the frequency is very high. Okay? So on the left side, where the wavelength is less, you will see gamma rays and X-rays. As you go towards the right side, you will get more wavelength in this direction. Here its wavelength is the highest compared to radio waves, but its frequency will be comparatively less. So these are the different uses, which can be seen here. So generally we do this gamma ray radiography by using nuclear fusion process. So this wavelength in nanometers is measured in nanometers. This range is emitted during the disintegration of radioactive nucleus. The process is also known as radioactive decay. So what happens in the radioactive decay is that your material, that is the nucleus, tries to come from unstable to stable form and it decays over time. So whenever a decay happens, or it is called disintegration, at that time you get different radiations like gamma rays, alpha particles, beta particles. The emission can happen in naturally occurring unstable isotopes and artificially produced ones. So here you can get this emission in two ways. 1. Naturally occurring means that there are naturally occurring isotopes which are naturally radioactive, meaning that you do not need to do any separate phase process or anything like that in it. And there are others which we use in radiography, like Irium-192 or Cobalt-60. So in this we use artificial process, meaning we use nuclear phase process. So in this you finally get R radiation, meaning gamma rays, which we use to do radiography. So in this actually unstable isotopes are used. We will see this further. So interestingly, gamma rays are very similar to X-rays in nature. So X-rays and gamma rays are almost similar. Only their origin is different, meaning that X-rays are produced in an X-ray tube, whereas gamma rays can be produced naturally or artificially. In fact, aside from their origin, both are virtually identical in terms of behavior and properties. So once gamma rays or X-rays are produced, their behavior, properties, i.e. their energy intensity, is similar. However, while X-rays are generated from an X-ray tube and produce a broad spectrum of radiation. So here there is another difference, that in X-rays you get a broad spectrum of radiation, meaning the radiation that you get is broad, meaning that you get to see more than one intensity. Gamma rays come from radioactive isotopes and emit specific discrete wavelengths of radiation. So in the case of gamma rays, specific discrete means that you will see a specific wavelength. This makes gamma rays particularly valuable in industrial applications where precision is crucial. So whenever we need more precision and have to do radiography of particularly heavy thickness, then we use gamma rays. So in this way, whenever this fuse process takes place, you get these gamma rays. Apart from this, alpha-beta particles are also obtained. So gamma ray production is rooted in nuclear physics. A nucleus consists of protons and neutrons that are tightly bound together. So here, any nucleus consists of protons and neutrons. This is very basic physics which you must have studied in our 10 standard, and these are tightly bound. They are connected to each other by a strong force. When a nucleus is in an excited and high energy state, it can transition to a lower energy level. So whenever a nucleus is in a high energy state, what will it do? It will try to come to a lower energy state. It will try to come to a lower energy level. And it will release the energy difference as a gamma ray at the right time. It will emit a gamma ray at the right time. Okay? So it will try to come from a high energy state to a lower energy state. So what happens is that, for example, Cobalt-60 or Iridium-192, if you look at them, they are in a very low energy state, which is natural, that is, they are their natural elements. So at the right time, they are bombarded with nuclear neutrons separately. So when there is a bombardment of neutrons, they come to a high energy state. So all these processes are done in nuclear plants. This process is completed in nuclear power plants, etc. So whenever the nucleus comes in high energy state, it will try to come to lower energy state, and at that time it will emit gamma ray. This process is unique because it does not alter the number of protons and neutrons. It only changes the energy state of the nucleus, making it more stable. Okay? So what happens is that whenever you bombard the neutron will increase. So it will try to come from unstable to stable. And the actual neutrons and protons will not change. Okay? What will the nucleus do to ensure that it does not change? The nucleus will try to come to its original state and try to become stable and emit gamma ray. So along with gamma ray, you will see that you also get beta radiation, meaning beta particle and alpha particle are also received. Okay? This is gamma radiation, meaning it is waves. Look here, this symbol is different. Here the symbol of gamma radiation is given like this. It means it is waves. Beta and alpha are actually called particles. You have to remember one difference. Beta radiation is electrons. It is called high-energy electrons. It means they are negatively charged. Alpha particle has 2 protons and 2 neutrons. Right? So remember this induction. Generally, a question related to this is also asked in ASMT Level 3 exam. So furthermore, gamma rays emits emission of follows other nuclear decay processes such as alpha and beta decay, which rays are the most penetrating type of radiation, making them incredibly effective for inspecting thick and dense materials. So alpha and beta decay also happen and are called particles. So this is a very penetrating type of radiation. It gives good penetration, but we do not use this in radiography. If you want to use thick or dense material, you can do so. But actually in industrial radiography, we do not use alpha-beta particles. Just look at its penetration capability, it will not pass through paper or skin. Alpha particles, if you take a 325 mm aluminum sheet, beta particles will not be able to pass through it and gamma rays will not be able to pass through lead sheet. That means it has this much penetrating ability. We have taken this example, it is specially taken of paper etc. But suppose you want to do heavy thickness, then in that case you can use alpha or beta particles. Right? But actually it is not used in industrial radiography. Okay? So you cannot compare metal and this paper. Okay? Because there are metals, it can pass through them. But they stop penetrating through paper or skin. So radioactive isotopes in radiography. Not all isotopes are created equal when it comes to radiography. Only specific radioactive elements are commonly used and they are typically categorized into 2 groups. So here, whenever we talk about radioactivity, there are 2 ways in which you can generate radioactivity, typically in 2 groups. One is naturally occurring radioactive elements, which means you will get radioactive elements naturally. Second is artificially produced radioactive elements. So by using artificial elements we do actual radiography testing. So let's talk about natural elements. So for practical radiographic applications, isotopes such as iridium-192 and cobalt-60 are frequently used, especially for medium to high thickness materials. So practically we use cobalt-60 and iridium-192, these are artificially produced. Right? Keep this in mind. These isotopes image gamma rays that can penetrate deeply into the material, making them ideal for inspecting welds, castings and structural components. Okay? So we do radiography of welding, castings, structures etc. using iridium, cobalt etc. So this is how you will see the camera. The instrument used in radiography testing is called a camera. So this is a gamma ray camera. Okay? Iridium-192. Apart from this, apart from iridium and cobalt, for thinner materials and small tubes such as those used in power plants, selenium-75 and ytterbium-169, sometimes it is also called white terbium, it is preferred due to their lower energy levels. So you can use both of these. In cases where the thickness is low, you can use both these sources. Although not widely used in radiography, cgm-137 has found its place in applications like radiometry and computed tomography. So both these options are available to you. cgm-137. So cgm-137 can be used in computer tomography or radiometry. So why do elements become radioactive? So we just saw that you get radioactivity in 2 ways, naturally and artificially. So why does the material become radioactive in both cases? So radioactivity often arises in elements with high atomic numbers. For example, elements with atomic number 82 tends to become unstable due to the repulsive force among the protons interested in their nucleus. So whenever there is atomic number, the atomic number of the material is above 82. Sometimes people say 82, sometimes they say 83. So in some materials, in some study materials you will find 82. In some you will find 83. So after that the material is unstable. So first of all, what is atomic number? So the number of protons in the nucleus is called the atomic number of that specific material. And you get all this information in the periodic table. This is the periodic table. You must have seen this in 8th or 10th standard. So just look here, as if there is one element in it. If you see, there are actually 109 elements. Right, there are more here. There are 118. Sorry, there are 118 elements in it, total. First, elements are just added to it from time to time. Actually, right? Earlier there were 109, after that there were 110. Now the latest element is 118. Okay? So, in this, whatever symbol of any element is given, there is some number written before or after it, so what is its meaning? Like it is written point, so this is platinum. Its symbol is platinum and on the top side, its atomic number will be written. It is 78 and if you see below, 195 is written, 195.1, so this is called the average atomic mass. Right? Atomic mass means the weight of the material, you can consider it. Actually mass and weight are both different. But if you calculate the mass of anything, then it will be called weight. Right? So now we will use the word atomic mass. So see, in this these elements become more stable form by emitting radiation, a phenomenon known as radioactivity. So the element will try to convert from unstable form to stable form. Right? So all the elements above 82 are naturally radioactive. So if you look here, this is 82. 81 is titanium. 82 is lead. Later there is bismuth. Olenium, right? So if you go further in this direction, all these elements are radioactive. Right? That means they are naturally radioactive. And sometimes in many generals it is said above 83. In general all isotopes of elements with a mass number greater than 206 and atomic number greater than 83 are radioactive. So you can also look at the mass number, which we had said is average mass. Right? Even if it is above 206, they are radioactive. Secondly, note down one more thing here. Cobalt and iridium which we use in radiography are here. See, this is cobalt and here is iridium. Right? So if you look at its atomic number is 27 and its number is 77. See? So it is not naturally radioactive. Right? What did we call naturally radioactive? This one is above 82, 83. It is naturally radioactive, right? But here, the iridium and cobalt-60 that we use are both artificially produced isotopes. Okay, so because of this, you do not see any natural radioactivity in it. And if you look at its mass number, look below cobalt, it is 58.93, meaning around 59. Right? So, we add a neutron to it, and it becomes unstable, and then it emits gamma rays, simple. So this refers to naturally occurring isotopes that are inherently unstable due to their large size and proton-proton repulsion. So, whatever is above 83 has natural radioactivity. Secondly, those which are inherently unstable mean they are naturally unstable and have a larger size because their mass is greater. Right? The number of protons and neutrons is greater. So, finally, proton-proton repulsion occurs in them. Right? That means, if there is positive charge together, then there will be repulsion. So in that case, they will be unstable and will try to come into a stable form. But elements with an atomic number less than 83 can also be radioactive if they are in an unstable isotope form. So, if it is below 83, you make it unstable. Right? If it is unstable, you make it unstable artificially, then in that case, you will get radiation from that as well. Especially when it is artificially produced. So this is why we are able to use cobalt and iridium in radiography. Right now cobalt-60 is made radioactive. So cobalt-60 is produced by neutron activation in nuclear reactors. So wherever there is a nuclear reactor, there is a neutron activation process. So what actually happens is that you must have seen that the contractor of RTE sends the camera to BRC from time to time for filling the camera. The camera is sent to BRC. So BRC is in Mumbai Bombay. All the cameras from all over India are filled there. That means there is a nuclear reactor there and there is a process of filling the camera, etc. So the process is called neutron activation. Right? So what they do is that they bombard the element in it and charge it, simple. Right? If they activate it, then its Curie will increase later and finally they send it back to the RT contractor. Okay, BARC means Baba Atomic Research Center, it is in Trombay. So what is in cobalt-60? Actually it is not cobalt-60. The one which is in stable form is cobalt-59. Okay, it is cobalt-59, which is naturally occurring as if bombarded with neutrons. So it is naturally. You will see the cobalt-59 which we saw. Okay, so it is written as cobalt-58.93. That means cobalt-59 is naturally occurring and neutrons are bombarded in it. So if neutron is added then later it will become cobalt-60. So cobalt-60 is unstable. That means it is an isotope of cobalt which is radioactive and emits high-energy gamma rays. So from it you will get gamma rays, particles, alpha particles, beta particles, etc. But in that we do radiography using these gamma rays. Simple, right? So this is the characteristic of gamma rays. If you are going to give PCN Level 2 exam, RTFI or RT exam, then many questions will come from this. So you have to be prepared for this. So I hope you have understood this video. If you have any doubt in this, then you can ask me in the comment box. Okay, thank you.